Alright guys, in this second video we're going to learn about the fifth operation that polynomials can use, and that's something called composition of functions. Composition of functions basically means you plug one function into another function. So the results of one function are used to evaluate a second function. So it looks like this. We've got, this is the official notation f with like an open circle g. That means f composed with g. What you're basically doing is taking f and then plugging in g of x. Okay, so if we work from the inside out, here's how it looks. So we start with some sort of value x. So any value of x you want, could be 2 or like -7 or whatever. So you take that value of x and you plug it into our function g of x. Okay, so you take x, plug it into g of x, pretty simple stuff so far. You're going to get a number when you do that. Okay, you're going to take that number and then plug that into f of x. And that's what you get. Okay, so you plug a number into g of x, then plug that into f of x. Okay, so I'm going to make a little note. So for right here, you plug a number into g of x, and then you're going to get a number from that. Okay, so then what you do is you take that number and you plug it into g of x. I'm sorry, I said g of x, I meant f of x. So plug that number into f of x. All right, so let's take a look at this example. First of all, something weird happened with the rest of my notation. It didn't print in the workbook for some reason. So this is f composed with g of x, and this is g composed with f of x. Okay, so just kind of fill in that notation. Then it says if they exist. So there's a chance that it won't exist. Let's kind of walk through how this works. So f of x and g of x. So what we're going to do is we are going to evaluate all of these functions. So we're going to start first with f composed with g of x. So remember, this is the same as f of g of x. So we're going to start with g of x, and we're going to take those values and try to plug them into f of x. Okay, so evaluate g of x first. So I'll make a little note there. Okay, so basically what I mean by evaluating g of x is we're just taking all of these points. So what the 0.70 means is if you take 7 and plug it into g, you get 0. Okay, that's what this ordered pair right here means. So I'm just going to write similar notation for all of these. If you plug -1 into g, this point tells me we get 7. If you plug 4 into g, I get 9. And then if you plug 8 into g, you get 2. Okay, so that's, I'm just taking these 4 ordered pairs and writing them down. So remember, I'm taking an x value, plugging it into g, taking that number, and then trying to plug it into f. Okay, so next what I'm going to do is I'm going to take this number and try to plug it into f. Okay, I'm going to take this number, try to plug it into f, take this number into f, and take this number into f. Okay, so I started with the inside first, started with g of x, now I'm trying to plug into f of x. So I want to see if there's a 0 as an x value on f. No, 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 yes. So this tells me when I plug 0 into f of x, I get -1. Okay, so now let's look for 7. That would be right there. When I plug 7 in, I get 7. Okay, 9. Here's 9 as an x value on f. So I know when I plug it in, I get 4. And then the 2, when I plug 2 into f, I get 6. Okay, so that's what those ordered pairs tell me. It's a little different than working with like a normal function. Okay, so let's write down exactly what this means. So for my domain and range, these are the initial values that I plugged in. These are the values that I ended up with. Okay, so this, my domain, these are the values I started with, 7, -1, 4, 8. Now these are not my range. These are the range of g, but remember I still had another step to go. This is the range of my composition function. So I have -1, 7, 4, and 6. Okay, so this is f of g of 7, this is f of g of -1, f of g of 4, and f of g of 8. Okay, so now let's do the second one. Let's go the other way. Okay, so now we want g composed with f of x, which means if we start from the inside out, we're going to evaluate the f of x first. So let's basically set up what we did. So we're going to take f of x first. So evaluate f of x first. Just remember with these, we work from the inside out. So all I'm going to do is copy down these ordered pairs just like I did with the g. So I know f of 2 gives me 6. That's my first ordered pair. I know f of 9 gives me 4. F of 7 is 7. And f of 0 is -1. Okay, I'm just copying these 4 ordered pairs into function notation here. So remember what I do then is I'm going to take these values and then try to plug them into g, kind of working from the inside out. So I want to take the 6 and plug it into g. I want to plug the 4 into g, plug the 7 into g, and plug the -1 into g. So that means that these are x values on my function g. So let's find an x value of 6. No, 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 no. I actually don't have a value of 6 at all. So this is undefined. Okay, if I look for a 4, no, no, there we go. Okay, so we got the 4. This is 9. Okay, let's look for the 7. Okay, we got one right there. So the y value would be 0. And for the -1, that is right there. So I get 7. All right, so part of my function is defined, part of my function is not. So the composition is undefined for that one value. It is defined for a couple of values, so we do get a couple of points. So let's write, actually, a good thing to write here, f composed with g would be to write all of my resulting ordered pairs. So 7, -1 would be an ordered pair. -1, 7 would be an ordered pair. 4, 4, and 8, 6. Okay, so that's just a list. That's my function from beginning to end. So for this one, my g composed with f, this was undefined, so I don't list anything for this one. This ordered pair is 9, 9. This ordered pair is 7, 0. This one is 0, 7. And that's it. I only ended up with 3 because one of my values is undefined. So for my domain, my 3x values are 9, 7, and 0. Order doesn't matter. If you want it, you can write it in order. And range is 9, 0, and 7. Okay, so that's how this process works if I give you ordered pairs. I'm going to show you what it looks like if I give you functions. Okay, so if I give you functions, you can plug one into the other. So remember, we're still trying to find f of g of x and g of f of x. So let's start with f of g of x. So remember what that means is I'm going to take g of x and plug it into f of x. So my function f, look at what's on the inside here. Remember this old notation if I had like f of 3. That means I'd look at my function f and I'd plug in 3 everywhere I saw an x. So what this means is I'm going to look at my function f and I'm going to plug in g of x every single time I see an x. So that's going to look like this. 3 of, and instead of x, I'm going to plug in g of x squared, minus, instead of x, I'm going to plug in g of x plus 4. Okay, but now we do know what g of x is, so we can actually plug that in. So equals 3. So now g of x is 2x minus 1. So I'm going to plug that in. Then squared minus 2x minus 1, and then plus 4. Okay, so I do have some simplifying that I need to do. So I can square this, which means I write it out twice in FOIL. And then here, careful with the negative. So minus 2x, but then minus -1. So that's plus 1. Don't forget you still have that 4 tagging on the end. So now let's FOIL this out. Leave your 3 out front. FOIL 2x times 2x is 4x squared. 2x times -1, -1 times 2x, and -1 times -1. Okay, combine up a little bit over here. I can add the 1 and 4. Okay, So just about done. We're just simplifying here. So distribute the 3. I can combine these up to a -4 and then distribute the 3. Distribute the 3 to that 1. Okay, so my last step, I will be combining all these terms. I have a 12x squared. My x is giving me a -14x, and my constants would be 8. So that is f composed with g of x, if I plug one into the other. So that's this first one right here. I also need to do the second one. I need to do g composed with f. So that means I go in the opposite direction. I take my function g and I plug in f of x. So this function is g. Remember, every time I see an x, I'm going to replace it with f of x. So 2 times f of x minus 1. Okay, I'm going to replace this f of x with its actual value. So f of x is this guy right here. And don't forget about the minus 1 on the end, and I can just simplify that up. So 2 times 3x squared, 2 times -x, 2 times 4, minus 1, and finally, just combine up those constants on the end. Okay, so that would be my final answer here. And since the video is already getting a little long, I am just going to skip over this problem.